Okay, welcome everyone. Welcome to the second presentation of this track, which is Stop Polling and Go Real Time. But before we dive into this topic, we want to start with a few words about ourselves. So I'm Mario, and I'm part of Accenture of Bratislava office. I'm a software engineer and also part of the technology track or architecture technology track. Usually, my day-to-day basis, I work with JavaScript, Node.js, and also Python and Elixir. And for the topics, distributed systems, event-driven architectures, and infrastructure, also operations to some extent, and some hobbies, mostly sports and traveling for the sports, all kind of sports from running to MMA. Everything is fine for me.
So, great. So, whoa, this is loud. Welcome to our talk from me too. My name is Kevin Bader. I'm also with Accenture Technology in the Vienna office. I'm with a group called Emerging and Growth, and we are concerned with emerging technologies. And I also do a lot of programming, also in Elixir and TypeScript and Rust mainly, but I'm also a theoretical guy, so I'm also into distributed systems, event-driven architecture, but also concerned with domain-driven design and strategical enterprise-y stuff. My hobbies are hiking, a little bit of calisthenics, and Go, the game. And feel free to reach out to me on Twitter and on email. So this talk is going to be about one of the projects I've been involved with both of us have been involved with over the past 3 years, basically, which is the Reactive Interaction Gateway. But before getting to the project, I want to show you how we got the idea in the first place. So when we started out 3 years ago, the idea was, or the objective was, to figure out how to apply modern architectures like event-driven architecture and modern development techniques to an industry that has a very traditional way of doing things. And we started with banking, of course. So we have this, on the one hand, we have banking, which traditionally uses something like a mainframe, a very centralized approach of software development and deployment, and just playing around with how this would look like greenfield if we would start from scratch today. We also wanted to create a state-of-the-art user experience around that system. And when creating state-of-the-art user experiences nowadays, you pretty much have to update everything live. So that hard reload that you have in the development experience also something that the user is accustomed to. Like, who of you has lately refreshed a website in order to get to see updated information? You actually do that still? That many? Okay, because when I'm on Gmail, for example, and I'm waiting on an email to come in, I'm not refreshing the browser. I just expect Gmail to figure out when a new email arrived and just show it to me. And also on Booking.com, you even get more notifications than you'd like to see. And all the news sites, news articles, news feeds, like if something happens in like political stuff or, I don't know, terror attack or whatever, and you're on a news site, there is a news feed that just updates. You don't refresh, hit a 5 like every couple of seconds. That is pretty much since Web 2.0 and so on, right? So this is there for a lot of websites and there for a lot of experiences. So it's nothing new. So using WebSockets wasn't something that we had to discover back then. It was already there. The problem was that we noticed that it's pretty hard to implement this at scale and with a nice developer and also deployment experience for a microservice system. And why that's the case, and on the next couple of slides I want to talk about why this is the case using an example. So the example that I take is, let's assume we're building a system for a conference registration, like OpenSlava. So we want to have, that's the example that everybody uses in this conference, right? Also, it's a pity that we didn't talk to Roman before. We could have used his app to show the front end anyway. So we want the system to implement 3 features. The first one is, of course, we want to allow people to register to conference. The second feature is that when someone has registered, we want notifications to be sent out to the organizing team and also to the participant. And the third feature is that we want to try something new this year. We want to have like a mentor matching service. So when the participant signs up, the participant should be able to select, like, I want to have a mentor. And then later on, when someone signed up that wants to be a mentor for someone, they will get matched, and the 2 people will get notified. So that's a mentor matching service that we want to have here. So how to implement this? Like the simple approach to implement this is to have one backend and one frontend. Surprise! So we create a backend that's called the conference service. Like stuff popping up on the screen. Conference service, which basically does everything. So those 3 features and more that I've described on the previous slide, just in that conference service. And then we have a front end. On the front end, you can submit that registration form. And if you want to do live updates for this, you want to create this rich experience where if you're still on the website and you get a mentor assigned, you should get an update right on the screen that you have a mentor now. Even though it might have taken a couple of seconds or even a couple of minutes, if you're on the website, you want to get that notification. So without a browser refresh. That's what I mean with live updates. If you want to do that here, you can basically use something like WebSockets or servers and events to hook up the front end to the back end. So that's, you can use Socket.io or any other of the frameworks. It's not really that complicated. So there is one source of data here and one source of events. Now let's take this to the microservice world. In a microservice world, you would split up the conference service into multiple services, depending on various constraints that are outside the scope of this topic. In this case, I chose 3 services: the registration service, which deals with the registrations themselves, so it does the form submission and processing and keeps track of all the participants. Then there is a notification service at the bottom that reacts to a domain event, which is published by the registration service, which is called participant registered. So whenever someone has registered, an event would be published, and the notification service would pick it up and send out the email notifications. And then for the mentor matching stuff, we would have a dedicated service. In that case, also the storyline around it is that this is a new service. We have a dedicated team for this. The registration service will probably not be changed that often, while the mentorship program is not quite sure what the requirements are, so they will change that a lot. So we have a dedicated service for this. This mentor matching service also keeps track of those participant registered events, and it keeps internally track of who wants to be a mentor, who wants to be a mentee, and also then emit an event called mentor assigned once the matching has been completed. So the data now is pretty much distributed because the registration service has no idea about the mentor. A user that registers on the website is a participant to the registration service, is a mentee or a mentor to the mentor matching service, and is a recipient to the notification service. So all those services have very much different ways of looking at the same thing. What we want to have on the front end in order to implement those live updates is we want to get those events that are emitted by the individual services and have data like the assignment and the date of registration and so on in them. We want to get them to the UI. And the question here is how to subscribe to events. And before we get into the details on this, we of course coded out that example, and we wanted to show it as a demo.
Yeah. Okay. So it's about the time to do something, and it's usually when everything broke. So let's see. Fingers crossed. So what do we have from the front-end perspective? Website where you can put your name, register, and it will, as Kevin said, register the user, create some events, find the mentor if there is any, and eventually notify the front end or send the email, right? And to have a little bit of idea what is going on, we have here this nice debug log. Let's open it. So if I put here some name like Mike and do register, I will receive a notification that I'm registered, and I should also receive, hopefully, that after a few seconds I got some enter. Right, you can see I received one notification and second one. And these debug logs are here just to show a little bit what is going on. So as we created some subscriptions based on the event types. And from the SSE, I received some event that it was confirmed. Then also that I got some enter. And we can also check that it's really going through SSE. That's great about browsers. That I have to do it one more time, and this time it will be John, because why not? And if we check the SSE and event stream, we can see that basically all the asynchronous actions are flying through it, that the subscription was created, we set some subscriptions, and we received one event, second event, which is then transmitted into the front end. Right. And yeah, that's, I believe, for this part, but we'll come back and deep a little bit more. No, that one. Okay.
So what you've just seen is exactly the implementation of that idea, that you have those services and you have those events, and the front end magically at this point subscribes to the events in order to show them. The idea behind this is, so we've implemented this with a project I will come to in a minute, but the idea behind this can be implemented without, you can implement it yourself even without the open source project that we will introduce. So the idea behind this is that the microservices emit events, and front ends can subscribe to this. And in case you're familiar with it, there is this concept of orchestration and choreography versus choreography. Orchestration means that some service is telling other services what to do, and choreography means a service just tells the world what it has done, and other services pick up that event and react to it. So in event-driven architectures, generally, services emit events and tell, yeah, okay, a participant has registered, and then some other services react to it, like the notification service, for example. But as soon as front-end enters the picture, suddenly it's not event-driven anymore. Suddenly there has to be some service, some backend for front-end service that tells the front-end to show something. And this is what we want to have is we want to have the same idea applied to the front-end as well. So instead of having, this is barely readable, but this means service A emits something and service B reacts to it, but service A tells the front end exactly what to do. From going from there to the front end can just subscribe to the events that happen on the back end. So we want to have the front end work in exactly the same way as all the other backend services work. This, of course, enhances decoupling, because suddenly there must not be there is no need for a single team to decide what the front end should show. And as Roman said in the previous talk, in case you were there, there is often a dedicated team for the front end. So they want to show something else, something different, or some additional data, and they have to talk to the backend guys first because they can't manage their own data subscriptions. The second point is that front ends should consume and produce events in the same way as other microservices do. The consumption part was on the previous slide. That's more about, so what I didn't talk about yet is producing. So every service can produce events and tell other services what the service has done. And the idea was to have the front end work in the same way. So you're probably familiar with stuff like click streams, where you save a user's actions for analytical processing somewhere in the cloud, on the backend, whatever. And this is pretty much the same idea. Like you do stuff on the front end, and the actions that the user does get emitted as events on the backend side. So you can say a user has changed the view, has selected something, has done something, And then the backend services, the microservices, can react to that. They can start some processes, they can analyze the user's behavior, they can notify someone about an action that has been taken, looks suspicious, and so on. The third part is that we want to have the front-end team and the back-end team decoupled. So we want the front-end team to actually be able to manage or select the data that they want to use on the front-end. You can start out with a very simple front-end, and then you realize on the back-end there is something going on. They also want to show it on the front-end, and you don't have to talk to back-end teams first, but you can just select the event that you want to show, and you will receive it on the front-end automatically. And what I mean also on the slide is topic partitioning should not be part of the interface. This is just an implementation detail, really. The idea was that the actual interface to the front-end team should be the event and not how the event is stored. So if you're familiar with Kafka, you typically do topics, and those topics are partitioned into petitions, and you have a petition key, and that might be, for example, a user ID. So all events that belong to a specific user ID go into the same topic partition, but the front end shouldn't really care about this because the front end should be concerned about event types. So this shouldn't be part of the interface. And of course, everything that we wanted to build should rely on open standards, which is why we created an open source project that implements those ideas. We worked on it internally for about a year and open sourced it 2 years ago. And it's registered as a CNCF landscape project, is on GitHub, Apache licensed. Feel free to check it out. Looking forward to issue reports and contributions and so on. At least you could give it a star. So what is it? What can Rig do? Rig is basically that middleware that supports the ideas that I've just described. So we have Rig as a component in the middle. Frontends connect to Rig, so the Directive Interaction Gateway, using servers and events or WebSockets. And then on the backend side, you can events are consumed by Rig using Kafka or Amazon Kinesis, or it's also possible to submit events using an HTTP call. And the important thing here is that the front ends actually issue the subscriptions to Directive Interaction Gateway, which maintains those subscriptions. So when a backend service submits an event using an HTTP call towards Rig, doesn't mean that it ends up anywhere. So if there is no one online, or if there are no frontends online that are subscribed to that event, it will just get dropped. So this makes it really different from other approaches. For example, SignalR, where the idea is to use something like a remote procedure call to have a backend trigger something on the front end or deliver information to a front end from because the backend wants to. This kind of turns that around. So on the backend stuff happens, and the front ends can select when they want to receive the information. The upside of this from a deployment perspective is that it also means that the Directive Interaction Gateway holds all the connection state and also does session management, and you can do stateless services even though you have a stream of events open to the front ends. So in case, for example, you're doing serverless, there is not really a way you can hold connections open or keep that connection state to front ends. So this is a component that does this for you, which in turn makes it easy to scale your services. Because imagine you're doing that, you're using Socket.io in your microservice, and you have scaled out your microservice, and you want to scale it in again because there is less load. Then you would lose all the connections all the client connections that are currently at instances that you remove. So to integrate this so the architecture picture would look somewhat like this. We have this component in the middle, the UI on top of it, connected using servers and events, and we have backend systems that have API business logic, their own data, they emit business events, and those business events get transported to the UI using Directive Interaction Gateway for this conference registration example, this looks somewhat like this. So the same picture as before, you see the three services. We use Kafka to store the events, and Kafka is consumed by the request action gateway, which forwards it to the browser, and that's what you've just seen earlier, where those notifications popped up. This is due to a event subscription that has been created by the frontend at the request action gateway. So now it's time for another demo. I want to show how this can be deployed, or works, how the deployment works in practice.
Yeah, so again, tricky part of the presentation. Well, let's see. So what we have right now is one Kubernetes node running locally thanks to the Docker that provides it. And we can actually check it out. So interesting. I should make it bigger. Is it enough? I hope so. So we can check pods, and we can see that we are running front end. We have Kafka with Zookeeper, a bunch of microservices, and also Reactive Interaction Gateway. And as you can see, we have also Grafana and Prometheus. So we can just jump there and see what is going on under the hood. We have just very simple metrics as an example for memory CPU, and then also requests that are flowing flying around. So each color is basically different requests, and then a bunch of other to see so how many requests was like HTTP or to Kafka, and then respective endpoints. Now regarding the scaling, one of the how can we scale, right? We have one replica of Reactive Interaction Gateway, but as Kevin mentioned, it's important to be scalable. So how can we scale it? As you can see, we don't have any type of database here, either for services or for Reactive Interaction Gateway. That means that entire state is in memory, which means that it's not fully consistent. But since it's written in Elixir and therefore in Erlang, it benefits highly from the benefits of the Erlang to work very well in distributed fashion. It's failover safe, and it's very good for real-time applications. And to overcome also, you should ideally have like at least 2 to 3 replicas to achieve availability. So what we can do is, do I have it saved? Yes, I do. So let's do 2 replicas. And in a couple of seconds, I should see its container creating. And I should have 2. And in a couple of seconds, this takes a little bit more because Prometheus is basically polling every 10 to 15 seconds. But what we should see here is that it will detect a second pod. You can already see it for memory. Same should be for CPU and then also for the HTTP requests. And if we do the same scenario as we did before to do some registrations, it should at some point start to evenly spread the requests across the pods. And right now we have only HTTP, but if you would have events, you would see the same for the Kafka events. That right now we have 4 partitions. As we have 2 pods, it will split partitions into 2, and it will also distribute it. So let's try to send a couple of requests here, and let's see what happens. And give it a little bit of time. Where is it? Here it is. So what should we see here in a couple of moments is same as was here, requests. This time it went to the single one. This is always sometimes funny that how it determines where it should go. But let's try a few more. Come on. Yeah, you can see that here is, let's do 5 minutes. You can see that suddenly here is few requests. It's 8 here, then some of those here. So it tries to distribute the requests across the pods, right? So that's how easy you can scale it, like you would do stateless services, and that's pretty much the same also for the events incoming from Kafka. Then do we want to also go through this, or do we skip it?
I will say a few words about it, maybe.
Yeah, okay.
So just because I've also mentioned it earlier about the partitioning scheme and what this means for the front end. You can see here that this should describe the event flow, so what happens technically from Kafka, how the events get from the Kafka partitions to the front ends. And the idea is that on the back end, the partitioning scheme might be anything. It might be by user ID, it might be by anything else. And Kafka nodes, they consume all the events, and they do some kind of repartitioning by event type. So to the front end, you only subscribe to event types, and you can also do additional constraints. Like an event type, for example, could be this participant assigned event, or a participant registered event, or a mentor assigned event that we've seen earlier. So that could be event types. And also, for example, if you consider GitHub, a pull request created, that could be an event. And then, of course, you don't want to listen to all pull requests in the world. You want to listen to pull requests for specific repositories or where specific users did something. And this is something that we call constraints. And so the subscriptions that you can do from the front end to the back end also says for event types plus a couple of constraints. So you can say on the front end, I want to listen to GitHub events for pull requests that have my user ID in somewhere in the pull request. And then it doesn't really matter how those events are stored on the backend side. So that's how the events flow. And another feature that we quickly wanna show is that we use Rig also for providing a synchronous API to an asynchronous backend. So when you do everything event-driven on the backend side, you have the problem that sometimes you have third parties that just expect you to provide a traditional RESTful blocking API. So we had this case where a client had a third party that said, okay, I want to do a request and I want to get the data, and I don't care whether I wait 5 minutes or 10 minutes, but I don't want to do another call, and I definitely don't want to do WebSockets. So okay, how do you do that? We're doing it by keeping the connection open and then producing a request event, producing the request towards the backend service, and then that backend service can produce the response. And that response then gets routed back to the connection that is still open to the third party. That was your part, actually. Yeah. Sorry about that.
Yeah. All fine. Okay, so
we want to show this, of course. So Mario implemented that on the demo too. So what you've previously seen on the demo was maybe you noticed that radio button was async, which basically meant that the response didn't come with the first request, but later on using the service and events channel. Perhaps you can see that here.
Where is it?
It's very small and unreadable.
Ah, sorry.
So maybe you just have to believe us.
Ah, okay.
Okay.
I can enlarge it. So this is basically the first way, right? So you send request, something happens, and server-send event will let you know I'm here, I'm registered, something happened, right? But the other way, as Kevin mentioned, is that so you can see here the com OpenSlava registration event something. So to have it clear, we can try sync. And let's try this one. And what we should see here is that I shouldn't receive any server-sent event, but rather I will wait for the initial request and receive the data there. Right? So if I do it, you can see I this time got sync registration confirmed, but no event. And if I check this call and response, you can see that I received here pretty much the com OpenSlava registration confirmed, and also the correlation ID. So that's basically the way how we are able to correlate request with the response. And maybe one more thing is what we didn't mention yet, that we are also able to push from frontends to Kafka more or less directly, where you can send an HTTP request and Rig will produce it to Kafka topic. This is especially useful if you don't want to introduce yet another service to just produce events. And this is also, as we mentioned at the start, the email notifications. So what we build here is very naive, but as you register and it flows to notification service, it puts you into queue. And within the 30 seconds, if you are not confirmed from the front end, it will send you an email. And the way how we do it is that if I register and I got the notification, if I close the notification, it will send a request to Kafka. And that way, notification service will receive, okay, user did something, he is aware, and I don't want to send him email, right?
And this is exactly what we said earlier. With we want to be able to react backend, to have backend events react to what the users on the front ends are doing. So if the user is actively acknowledging something or doing something so that the UI knows that the user actually read something, then a backend event can react to this, and the notification service can say, okay, the user already read this, I don't need to send out an email for this.
Yeah.
So the last two slides before lunch. So why should you care? So as a backend developer, the cool thing is that you can emit business events as usual. You don't have to use any fancy SDK or do some special code handling, special code path for handling the UI. You just emit events, just like you would when interfacing with another microservice on the backend. You don't have to bother about connection handling, so you can really create stateless services that you can scale easily, and handling state or connection state when scaling out and scaling in is really nasty. You don't have to do that.
And I would maybe hear there a little that the scaling is really important, mostly for the operation perspective, because if you used, like we are using Kubernetes, if you are using Kubernetes for a longer time and you're doing operations, and you had to take care of volumes and data, you will tackle some issue at some point. So it's not that easy to take care of the data and volumes, and therefore it really makes life a lot easier also for the operations.
And from a front-end perspective, you can create new user experiences with this. You can think about the stuff differently. You no longer have just like this backend response that you have to work with and just display stuff, and and wait for the user to take the next action, and then wait for the backend to provide the next data. But you can take a look at what data and what events are already there in the business. There are always a lot of events involved in those processes. Like, for example, if you do a bank account transaction, you could see it like you do a transaction, you wait until the transaction completed, and then you get back to response. Or you could see it in a more realistic fashion. You trigger a transaction, you get a confirmation that the transaction will be processed, then the processing is going on, then the amount of money is actually transferred. So in reality, most of those processes are actually multi-step processes, and you can react to those steps and let the user know what they're trying to do, where it currently stands. And you get a lot more freedom as a front-end developer if you do it that way. So to conclude it, we think that real-time UI makes for a great user experience. And not using real-time data often makes for a bad user experience because a lot of people, apparently not in this room, but are really used to not refreshing the browser. So if you're looking at stale data, it might annoy a lot of people. And this idea of extending the event-driven architecture to the front end decouples front end and back end, and kind of makes the front end raises it to the same level of importance as the backend teams, which I think is really nice. And the Reactive Interaction Gateway is our project to enable this. It's an open source project, but the general idea can be implemented in any other way too. So I want to close with this slide, and which kind of summarizes this again. And yeah, do you have some questions?
Or you want to run away for lunch?
Or lunch, questions or lunch. We have 3 more minutes. Yeah. We're happy to take questions. Yes? The question was whether we are able to target specific devices. You can do that using subscriptions because you can have those constraints. Like for example, if on a specific device you're only interested in a subset of events because you don't want to get that many events because of battery life. You only want to get the most important ones and not like every advertising stuff that you show on the website. Then you can have, so the subscriptions are per connection. So for those devices, for those UIs running on those devices, you can just use fewer subscriptions or more specific subscriptions, and then you get another different set of events.
And you can also use constraints in a way that, okay, this event is, for example, targeted only for a given users. Or it depends, for example, if you have something specific in event, that this is just this device event, you can subscribe to that, and it will be consumed only. You will consume only that event, right? So you can constrain in it any way you want, basically.
Yeah. So the question was whether using this also makes sense if you don't need the scalability. I would say yes, because it makes it very easy to get started. You can, even if you don't use Kafka, for example, and you just want to focus in your application, you can just bring up rig as a Docker container, and then use its HTTP API to send submit messages to it. And then you hook up your browser to rig, and you don't really have to. It frees you from the burden of handling the connection state. You don't have to look into how to make, whether to use WebSockets or service and events and blah, blah, blah. It just does it for you. Of course, you can do it, but it's less implementation work on your side, and you just have to spin up a Docker container. So I think it still would still be good to use it, yeah.
And I would say that also you can edit more or less at any point of time during the development. So you can start with your WebSockets, but since we're also supporting WebSockets, then you can edit a month later and just connect to rig, and it will do WebSockets from there, right? So it's pretty flexible.
By the way, we also have support for long polling, which is also usable if you're behind an API management gateway.
Yeah.
And
security.
Yeah. Okay, thank you very much.
Thank you.